Just a video on v equals u plus at, which we've done in class. So we've done a bit in class. Like we discussed, v is final velocity in meters per second. U is initial velocity in meters per second. That's a posh word for starting. A is acceleration in meters per second, or meters per second squared, and t is time in seconds. So using this formula, v equals u plus at, which we can rearrange in its various forms. So the first one, I've got a car accelerating at 2 meters per second every second. Quite fast, really. From rest, so it means the starting velocity is 0. Over time of 30 seconds, so we know t is 30 seconds, it's the right unit, that's the right unit. We need to work out a final velocity, which is going to be v. So we know a is that, we know u is 0 because it's from rest, we know t is 30 seconds, we need to find v. So we'll use that formula, v equals u plus at. We know that u is 0, so we can get rid of that, and a is 2 and time is 30, so 30 times by 2 gives me a final velocity of 60 meters per second, which is a bit unrealistic, but it's just the numbers I've used. So a nice easy example using v equals u plus at. Number 2, this one's a motorbike. It starts off, initial velocity is 0.2 meters per second. It accelerates at that much, 0.5, for 1 minute. Don't forget we need to be in seconds. We need to find its velocity after that minute. So we need to find v, the final velocity. So write down what you know. U is 0.2, A is 0.5, and t is 60 seconds. Because 1 minute is 60 seconds. V equals u plus at, there's u, 0.2. A is 0.5, 0.5, and t is 60 seconds. Put 60 in there. Make sure you put a bracket around that. So on your calculator, you can do this. 0.2 plus, open bracket, 0.5 times by 60. Close the bracket, will give you the answer, 30.2 meters per second. Again, which is a bit fast. Because don't forget, it's constant acceleration, so it's accelerating that much every second. That's why we get big numbers. So another nice easy example using v equals u plus at. Scroll down, different color pen. This one's a train. Accelerates from an initial velocity of 0.3, so there's my u value. 30 seconds, there's my t value. It reaches a final velocity of 2 meters per second. So we know v. And this one we're going to work out the acceleration. So we're using that formula again. We know v, we know u, and we know t. We just don't know a, so we've got to rearrange for acceleration. So v equals u plus at, I'm going to bring this positive u across, so v take away u equals a times t. And then bring the t down there, so v take away u all over t is a. You could also put a bracket around there if you want to. V minus u divided by t equals a. U is 0.3, t is 30, v equals 2. So using that formula there, a equals 2, take away 0.3. So 2 take away 0.3 equals that, divided by 30. Gives me 0.056. So that's my acceleration. Number 4, same type of thing. Car brakes. We've got initial velocity of 2 meters per second to a standstill in 15 seconds. So we're calculating the deceleration, slowing down. It's going from 2 down to 0 in 15 seconds. So there's my formula again. A equals V take away U over T. So the final velocity is 0. Guess we've got that. So then car brakes. So it's going down to stop. So V take away U. So V is standstill, so it's 0. U is 2 because that's off at 2, and the time is 15 seconds. So V take away U is T. Don't forget we're slowing down, so we're going to get a negative number because V is 0. Take away 2 minus 2, obviously, divided by 15 gives me minus 0.13 meters per second. It's slowing down in the opposite direction. That's why we get a negative number. So they're just some nice and easy examples using V equals U plus AT. Over and out.